Hello everybody, my name is Marco Biasizzo and I'm very happy to share with you our research project concerning a multiscale network model that we built to investigate the basal ganglia and cerebellum interplay in Parkinson's disease. It is known that Parkinsonian patients suffer from dopamine depletion, which alters basal ganglia activity. Recently, it was proven that also cerebellar functioning is modified in Parkinson's disease, so we tried to investigate the causes of cerebellar alteration. Thus, we built a multi-area, multi-scale network involving cortex and thalamus, represented as mass models, and also basal ganglia and cerebellum, simulated as spiky neural networks. The activity registered from the cortex is then delivered to a cerebellar controller, applied in a simulated motor task. The weights of the connections between the areas were optimized with a genetic algorithm to reproduce healthy rats data. Then, the dopamine depletion parameter, defined inside the basal ganglia model, was modified to test Parkinsonian scenarios of variable severity. To conclude, the cortex activity registered in Parkinsonian conditions was applied to control an inverse pendulum. The complete network, represented here, is composed by three models we selected and replicated from literature. The Lindahl and Kotalevsky model of basal ganglia, composed by 80,000 of Itzikevich and adaptive exponential integrated fire neurons. The cerebellar model by Geminiani et al., with more than 90,000 EG-lift neurons, and the Yusif et al. Model, which represents cortex and thalamus with Wilson-Cohen formalism. Once the multi-area, multi-scale network was implemented, we verified that the resulting model could reproduce the average firing rates of the original models taken singularly. Then, we reduced the amount of dopamine in the basal ganglia, and we registered the variation of the average firing rates of both basal ganglia and cerebellum. Moreover, we obtained an increase in beta bands and theta bands power of cortical wavelet transformation. Conclude, the cerebellar controller involved in the motor task show faster learning capacities in mild Parkinsonian condition, while in severe Parkinson's disease simulations, more trials were required to perform the task, still obtaining a worse performance. All these results are coherent with experimental data recorded in mice and in humans. I would like to thank you a lot for your kind attention, and please feel free to contact me for any further clarification.